What we're going to talk about today is good design, sustainable design. We're going to be looking at affordable pathways to moving towards net zero energy and how to do that on any project. Some of the learning objectives I'll go through quickly. We're going to be talking about resilient low carbon communities and how to create those. We're going to be talking about sorry guys, how do I turn off the camera thing so it's not my way? There we go. All right. Okay, so we're going to be talking about certain, a host of sustainable design technologies that can contribute to net zero and low carbon buildings. We're going to be talking about just best practices for high performance building design and how to get those incorporated into any project of any size and budget. We're going to review some case studies, and these bottom three are mostly what Matt's going to be providing. He's also going to be walking you through the various financial incentives and tax credits that are available to architects, builders, and owners primarily through the 2022 Inflation Reduction Act. And we're going to be talking about the benefits of occupant health and social well-being. Some of the things that I'm hoping that you'll take away, or at least will be memorable today, in addition to the learning objectives. I'd like to just kind of set the table here and remind everybody that architects truly are, guiding the design process through our leadership and our influence on the design team, the design vision, and our relationship with the owner. We have a lot of influence there, and we need to use that to move our industry in the direction it needs to go. Architects are really the tip of the spear in terms of making design decisions. Our industry affects 40% of global emissions, and I'll talk about that in a little while. However, I think this is a really exciting time and exciting opportunity to be able to realize as a profession that we also have a 40% impact on fixing the climate problem. We also want to do something and do as much as you can, just setting measurable performance goals. And what I like to say is just ask the question, pushing the AE team and looking for ways to make this happen. You also don't need to be an expert to be an advocate for sustainable design. You don't have to be a lead AP. You don't have to, if your office like rarely, if ever, does any kind of sustainable buildings, you don't need to be an expert to be able to incorporate some of these simple tools and to advocate for going a little bit above code with each one of your projects. And then we're going to just talk about, how to move towards net zero carbon buildings. It doesn't have to be, an all or nothing. I think in my career as a, commercial architect and doing public sector projects, it was frustrating because I would push for it and clients would say, no, I don't want that. And I kind of didn't know what to do. If they didn't want to lead building, I kind of felt like I was, that's all I could do. So hopefully this presentation, you'll be able to see that there are some really, really great measurable things you can do while keeping your projects on budget and on schedule. And Lao Tzu, said this famously, the journey of 1,000 miles begins with a single step. So we have to start someday. Ed Masry is one of my kind of folk heroes. He's talking about, not overcomplicating the problem. He said better buildings and responsible energy use and renewable energy choices are all we need to tackle both energy independence and climate change. I also want to kind of relate a really quick story. I was at UNLV at the School of Architecture when Ed Masry came to speak to the students probably 15 years ago. And it really made a big impression. This is before I'd started our sustainable design practice here. I was still, driving myself crazy as a commercial and architect, and I was, not sure what I was going to do with my kind of encore career. But he came and spoke, and I think it really had an effect on me. He was laying out all the scary, kind of depressing statistics about climate change and how once we get to 1.5 degrees Celsius, you know what's really going to hit the fan, and architects have and will be a big part of that problem, by how we have been designing buildings, unsustainably, and doing next to nothing. But he said, what really encouraged me, he says, but think about it this way, reframe that thought, that when in the history of mankind has have a group of professionals, just designers, engineers, contractors, um, when in time have that small group of people been able to affect literally the future of mankind, the livelihood, of, and the security of mankind surviving. And that's what's going on in our lifetime. In the next 20 to 30 years, we can either fix it, or we can make it worse. So I see that as an exciting time. And our buildings truly will outlive us. The largest wave of building infrastructure in the history of the world is expected in the next 30 years. And the amount of floors of built floor area is expected to double in the next 30 years as well, 35 years. And that translates to 4.4 trillion square feet by 2050. And to put that in a little bit of scale, so that's the impact we're having just every day with our design decisions, and also our as we're retrofitting existing buildings as well. And to kind of put that in perspective, sorry, one second. How do I show notes, Stacy? Sorry.
Is that on your slide?
Yeah, I guess I have to go back to that. I'm sorry for the delay.
Do you see it on your screen?
No.
Oh, okay, because we're only going to see what's on your screen.
Yeah. I just had some notes to myself that I wanted to be able to reference, but whatever, I can hang with it. But to put this in perspective, this amount of square footage is the equivalent of building a city the size of New York, like every 4 months for the next 40 years. That's the scale of this issue. The impacts of building design decisions, these daily decisions that I'm talking about, are 42% of global emissions are coming from building operations. So, the energy use, building construction, all the materials that go into it, and so the operations and the construction are 42%. So that goes beyond transport, industrial, and agricultural emissions. And all buildings really do matter. I think it's easy for us to kind of rationalize that, like, well, the kind of clients that I have aren't looking for high performance buildings. They don't want, LEED Platinum buildings or net zero energy, or my projects are just too small. We don't do hospitals and high rises, so we don't have the budget and the sort of design program that would require that would kind of justify a high performance building. And we really have to get out of that mode of thinking, because as you see, small buildings, are comprise 95% of all buildings that are constructed, and 50% of emissions. On the flip side of the coin, for those of you that work on really large projects, you can see that a very small 5% number of 5% of total buildings equal the other half. So that's an incredibly tall order, no pun intended, but big buildings you really have to be careful about how we're designing large buildings, because it's a gigantic opportunity and a gigantic failure if we don't.
Hey, Rick, I might,
Yeah,
Rick, do you mind if I interject one
anytime.
piece of information that might be useful that goes along with what you
Mhm.
were just talking about? Because we run into that issue frequently also on our side of the business where customers often will say to us, well, I don't want to pay for the better stuff. I don't want to pay for more high efficiency. Just give me the basic stuff. Well, analysis tells us, our experience tells us, frankly, that the life cycle cost analysis of the incremental cost associated with a high performing building or a high performing system actually does pay for itself. And it goes to the slide before that you had that talks about the life cycle of buildings, that they frankly are going to outlive us. I think so often building owners and developers and others get caught up in initial first cost. And while that matters, the reality is that buildings do have a very long life cycle, and it's very worth looking at that incremental cost because of what it means long term.
Yep, exactly. That's a really great point, and it's critical, Matt, because so often during the early design process, even in initial conversations with the AE team, you know, a lot of good ideas and a lot of really good scenarios get thrown out because just based on a first cost, like, hey, that's expensive, or that's more expensive, X is more expensive than Y, so forget about it. Or even like we tried that on a previous project, and it was too, it got thrown out or value engineered, so therefore I never want to do that again. So really thinking about long-term life cycle cost, and also just we'll get into it in a little while, but just evaluating return on investment, a simple ROI analysis on payback. If it's 5 to 10 years, it's usually acceptable to owners. Hey, Stacy, can you see my screen full scale, or
No,
no?
we
This is the
actually
short one.
see PowerPoint, and we see that the slide is small there.
Okay.
So we need to go, yep, there we go.
Okay. I think. Sorry, everybody. Oh boy, I knew this would happen. All right, I'm gonna roll. I had some notes here in case I got nervous, but anyway. So I just kind of want to get on a soapbox here for a few minutes because it's really important to think about concrete and the importance that it plays. It's um, apart from water, concrete is the most widely used element on Earth, which is kind of mind-boggling. And it also consumes, the production of it consumes 10% of global industrial water use, just making concrete. And a huge, and like 75% of that concrete used is being extracted and produced in areas that are short of water. So I think that those things together, and it's by far the most the worst carbon emitting material that you can use. So and to kind of illustrate it, um, if the way you make concrete, the way you make Portland cement is by burning limestone at like 4,000 degrees Fahrenheit. I mean, so of course you're burning rock in order to make the glue that makes concrete happen, makes concrete work. So we'll get into it in a little while. However, I just kind of want to point to this article, and if you ever want to just really get a completely different perspective on concrete and how bad it is for the environment, you'll probably, I guarantee, if you read this Guardian article from 2019, you'll come to the same conclusion that I did, and that's that I have a completely new perspective of my favorite modernist architects, Ondo and Louis Kahn and Corbusier, with these concrete structures. I don't think they're nearly the geniuses that I used to. I kind of wanted to get into a little bit of the AIA Code of Ethics as well. So in I think 2019, the AIA voted as an organization, and something like 95% of members voted um, to make sustainable design part of our health, safety, and welfare charge, right? So what the members voted for, and AIA members are very, politically all over the map. And I don't really particularly consider the AIA an environmental organization. However, it was very encouraging that the membership, by that gigantic of a margin, voted that it's an existential thing that architects need to get involved with, to promote healthy environment and to preserve our resources. So I just kind of want to go through this really quickly. That that energy conservation, water use, building material choice, protecting natural habitat and ecosystems, and designing for around climate and climate change, designing adaptation strategies to minimize the effects, and to protect the public health. So these are ethical standards that are like, we should be doing this as a profession, and if you're doing your job right, you should be doing these things. And in the code of ethics, so those are the ethical standards, but the AIA also, and regardless of whether you're an AIA member, right? Maybe you're watching this, and you're one of those, what I call the kind of fair weather AIA members who sign up for the year-end CEU seminar to get caught up, or you sign up so your firm can submit design awards. No judgment there. But even if you're not an AIA member and you call yourself a registered architect, I think our profession, living up to these standards is something that we should all strive to do. And if you're an AIA member, there are actually rules in our code of ethics that say you have to, when performing professional services, you must make reasonable efforts to inform our clients of the potential environmental impacts or consequences that our members reasonably believe may occur as a result of work performed on behalf of our clients. And members shall consider with their clients the environmental impacts of their project decisions. So it's our goal, it's our charge and our obligation to inform our clients of of the benefits of sustainable design, and also the importance of sustainable design. And specifically setting ambitious building performance goals. And I want to note that code minimum design should not be confused with, quote, ambitious goals.
Rick,
So now we're going to get in. Yeah,
Rick,
go
I have
ahead.
a couple questions before you get into this next section.
Great.
Okay. This one, you may be covering this later, but I will ask it. It says, is there an AI program or book to evaluate life cycle costs? If so, this would greatly empower architects to sell clients to environmentally responsible projects, to design environmentally responsible projects.
Yes, there are some software and some free utilities that we list in the resources towards the end of the presentation. And then there are a couple of books that we use as references in our office a lot. So you don't need, the answer is yes, and you do not need to sort of wait until 50% design to get a full-blown detailed cost estimate to do a super detailed life cycle cost analysis. There are some really good tools out there to just be able to get to help make those preliminary design decisions. The kind of no go. Is this product or is this mechanical system or this envelope design, these windows, is that going to be a 5 to 10 year payback? Is it going to be a 1 year payback, or is it going to be a 20 or 30 year payback? That's what helps make those decisions. Is there another question?
Yep, one more question is, how are we going to account for emerging third world countries as their only resource is concrete for building materials?
I've thought about that many times, and it's incredibly difficult. But I think leading by example, and also using using more regional materials, lower carbon materials, and creating, you know, industries here that we can export those materials to those countries, because a lot of those countries have been, you know, practicing massive deforestation for many years, so they don't have, you know, sustainably managed forests like we have, you know, all over North America. So I think there's uh, all we can do is really lead by example.
I think those are the only questions we have right now.
And there are other technologies as well, rammed earth and rammed rammed earth blocks, you know, like Adobe blocks, and bamboo structures. There's a lot of reinforced Adobe with straw and fiberglass. There's a lot of kind of systems that are out there available that are fairly high labor. They're fairly labor intensive, and those systems are often very good for third world countries and developing countries, because their resource, they lack resources. However, they also really need to make jobs. So you know, sort of what we consider in the United States, you know, high labor systems are usually bad. We'd rather pay a little more for materials and lower our labor rate. So anyway, so it's a pretty fascinating field. Okay, we're going to move into some of the regional climatic factors. So I just kind of wanted to set the stage for the impact that architects make, and how how it's our obligation to do the best we can, and we can, you know, it's far too late to just sort of leave it in other people's hands and say, you know, hey, that's not the kind of architecture I do. I don't really know about that, and my clients don't ask for it, so like I'm off the hook. So um, now we're going to sort of get into some of the regional factors that affect northern and southern Nevada in our, you know, which are both arid regions. So to address resiliency and climatic design in northern Nevada, there are some certain factors here that are pretty important, that need to be factored into most projects, but particularly those that are sort of at the periphery of the urban areas where the wildland urban interface is. We obviously don't have that issue in southern Nevada. However, I have worked on projects in California, and it's amazing to see these, you know, fire maps where I didn't even think a city was anywhere near a forested area, but you know, 2/3 of the city is in a pretty serious fire zone. So that's a big difference from where we were 20 years ago. So in terms of choosing roof materials and also structural systems to make sure that we're, you know, providing resiliency to fire. But these cities also have to deal with emissions and general air quality as well. So wildfires are happening, you know, kind of all year long now. And also water availability and quality. The Truckee River watershed, keeping that clean, and also, you know, the whole Tahoe Basin is a national, worldwide treasure. So keeping those places clean and usable are part of the whole economic matrix as well, to continuing to bring tourism up to northern Nevada. Stormwater management and runoff. This is a problem both in the north and the south, where we get, we don't get a whole lot of rain, but when it comes, it's very fast. So managing that on site. In southern Nevada, we have a completely different issue in terms of return flow credits to the Colorado. However, in northern Nevada, especially Reno, Sparks, and Carson valleys, you really have to pay attention to on-site water runoff mitigation and also on-site treatment. So we want to make sure that stormwater that has oils and other toxins in it, is getting treated before it gets into the aquifer and before it gets into the stormwater system. And just in terms of social justice and equity, this is again one of the ethical standards that the AIA recognizes, that low-income communities, inner city communities, communities of color are affected much greater as a result of climate change, and those communities statistically also have a lower ability to mitigate those and to be resilient. So our decisions about heat island effect and just dealing with extreme heat, promoting more rapid transit and public transportation, providing a larger tree canopy in both the north and the south for shade, and also open space, more parks and more green space to counteract all the pavement that's causing the heat island effect. And also for food security and access to healthy foods. It's not as big of a problem in northern Nevada. However, there's still most of the fresh food is imported from California. So when there's fires and floods and different things happening on our freeways, it can really put our food system in jeopardy. I remember about 10 years ago, there was a huge storm like north of Las Vegas that washed out like a mile and a half of the I-15 freeway that connects to Salt Lake City and southern Utah. And that freeway was shut down, for I think like less than 3 weeks. But it really made it very aware that these food deliveries from Utah primarily, but also further east. There's only one road into Las Vegas coming from that direction, so they had to go clear around and add 2 days of travel. So similar to the whole COVID epidemic, there are these these supply chains and everything, when they're disrupted by climate, they're becoming a much bigger problem that we need to be thinking about as we're designing our communities. And I have a question for everybody. Are there any other design factors you've experienced, in your region? If you're from the high desert, northern Nevada, even kind of rural areas, if there's some other climate factors and urban design factors that you've experienced that I'm not talking about here, can you just put those in the chat, please? And we'll get to those in a second. So this is a
do you want to hear those as they're dropping in, or do you want to wait?
Yeah, let's go with them now.
Okay. We've got wind, geothermal. Wait for people to type. Green roof, power grid,
yeah, those and I get asked that question a lot. Why don't we have more wind? And there's wind is really more effective when it's a constant supply. So that's why we have some really large wind farms in kind of central Nevada, outside of Ely. You really need to have kind of a sustained 7 mile per hour wind to kind of make it pencil. And we have a lot of geothermal, active geothermal energy sources in northern Nevada, but there are also really great possibilities of using geothermal heat exchange, as just a fluid heat exchanger to preheat and pre-cool our mechanical systems as well. That actually can work in both climates.
We also got snow, water use reduction, and recycling.
Yep.
Fire
So,
departments, they have fire departments requiring defensible space.
exactly. Yeah. So we're going to talk about the wildland urban interface here because defensible space, if you're anywhere near the interface or the intermix zone, you're required to have required to have a type 1, non-combustible roof and have that defensible space around there. So with like low vegetation around the buildings. So you can kind of see the highlighted areas here where this is showing the interface of like the vegetated areas and also the proximity to higher fire incidents. And in the Tahoe and Carson Valley area, same thing. But you can see the intermix area, and I'll show another graphic here in a second. It's really surrounding these urban areas, and in the green is just showing where there's no housing now or very low density housing as well. I'm sure a lot of you remember the Paradise Fire in Northern California near Chico. This aerial was just mind-boggling. That you can really see just how this fire was just literally a windblown tornado. That just blew through that town, and nobody had time to react. So it just really illustrates the importance of having a citywide and regional approach to fire prevention, and also in the urban areas being able to design houses that are more resilient and more fire resistant, basically to give people time to get out. It's not at all different from designing fire protected or fire resistant walls in buildings. And here's the continuum that I kind of talked about that shows the kind of from wildlands to the intermix area to the interface, and what's called the occluded, then the ember zone where windblown embers can still reach houses. So even if there's no vegetated area, if it's close enough to be blowing embers, especially in these huge winds. And you have to remember that these giant fires, they actually create their own weather systems. So they're akin to small tornadoes, and so they can throw burning embers for literally miles. And then the bottom graphic it kind of shows each of those. So Tahoe up there, in the mountains with the up in the pine trees and everything, and then down to kind of the foothills, and then the valley at Carson Valley, where it gets more dense and where it becomes more just street trees. So particular to Southern Nevada, we obviously have it's hotter, it's even more arid, and we have water supply issues. And we're 100% virtually 100% reliant on the Colorado River. We have extreme heat and urban heat island effect. That we don't get the cool nights. We're not able to open the windows really at night in the middle of summer, as you are in Reno and Carson for a chunk of the year. There's also we need a lot more tree cover and a lot more frequent public transit options. And there's generally, I think our city has traditionally been fairly transient, right? So a lot of people that move here, families that live here, they don't have generations of family members living there and support structures that they can lean on. We also, in the last year, I think a little over a year maybe, the Southern Nevada Water Authority enacted a ban on evaporative cooling. So any kind of from industrial to residential, and eventually they're gonna I think they're going to even ban misters, outdoor misters at restaurants and so forth. So that's been a real game changer, and it's forced our community. And Matt's going to talk about that a little bit later about how a lot of these large buildings, distribution centers, warehouses, even data centers are having to move away from getting free cooling basically by evaporating water, because we can't afford to do that anymore. So now we have to find ways to to supplement that with electric equipment. And then back to the environmental justice aspect that I mentioned before. Las Vegas sadly has a 75% poverty rate, or a high poverty rate, and 76% of kids qualify for free and reduced lunch. And the hottest areas are also the most vulnerable populations. So I'll show that in a second. But this graphic here just kind of shows that in Las Vegas, a lot of parents look at the weather forecast to see what their child's dealing with, at the bus stop.
Hey, Rick, I might make one comment based on
Please.
your weather forecast that you're showing there. For those of us that live in Phoenix, when we see those kind of temperatures, we call that a cooling trend.
Yeah. This is a pleasant spring day in Phoenix. So
Yeah, we only
yeah.
had I think close to 70 days over 110.
Right. Yep. So, and then here's a little probing question, for those of you that work in Phoenix, Las Vegas, other hot areas, what are the other factors that you've seen that need to be, that we need to account for in our design? And this is the Regional Transportation Commission created these maps. They did a study in 2021 looking at basically a vulnerability analysis based on urban heat island and extreme heat. So the map on the left shows where the hottest parts of the valley are, and it's primarily based on elevation. So the lowest parts of the valley are towards the east. So it's East Las Vegas out by Nellis Air Force Base, and then east, kind of northeast Henderson as well. And the prevailing winds generally kind of go northwest to southeast. So those low areas also have the highest particulate matter, the highest ozone. So they're the hottest places. They have the least amount of tree cover, the least amount of open space. It's just a lot of hard surfaces, large parking lots, not a lot of trees. And coincidentally, that's where most of or a large portion of the low income population of the Las Vegas Valley lives. So the graph on the right kind of shows that. So these are the low income neighborhoods, and they're the most vulnerable to extreme heat, and they just don't have the resiliency to be able to adapt to it. And I'd like to kind of relay one kind of personal story. Several years ago, my wife's grandparents, they're in their 80s and lived by themselves in an old neighborhood that was built in the 40s, near downtown Las Vegas, and lived there forever. Actually, they lived there since it was built. We had a heat wave that summer, and I think it was up to 116, 118, I think. And this house just had a single swamp cooler, and her grandfather was, a notorious cheapskate, and just never wanted to put in central air or anything. So, but my wife hadn't heard from them in a few days, and was, so we got a little worried. So we and didn't answer the phone. So we went over there to check on them, and they were both laying in their bed with two fans blowing on them. The swamp cooler was broken and had been broken for like a week. And they were laying there completely dehydrated, still alive, but we're all pretty sure, within a couple more days, they probably would have passed away. So, and these are people that had someone they can call, right? But because a little bit of there was kind of some Alzheimer's involved there, but I think it's just a really painful example of how easy it is to when you can't adapt or think you can't adapt, it's literally life and death choice. And just real quickly on the consumptive water use, this is a huge deal in Southern Nevada because like I said, 90-something% of our water comes from the Colorado River, and we recycle almost over 90% of that water. So, and everything that goes into our sewer system gets treated and then goes back into through the Las Vegas Wash back into Lake Mead, and then we get to take out that same amount. It's called return flow credits. So we get to extract the same amount of water that we recycle. And that's about 300,000 acre feet a year, by far the lowest state allocation of all the Colorado Basin states. And we're stuck with it. We're just not going to get any more water. So what our community has to do is, aggressively conserve. And then we also have to, look for other sources because we're still a growing city, like approximately 5,000 to 7,000 people are new residents are moving to the Las Vegas Valley every month. So, and our economy is continuing to diversify, thank goodness. So we have to keep that growth going, but we have to do it in a sustainable way. So, it's been actually incredible over the last 30 years to witness what the how forward thinking and intelligent the water authority has been. Because they've been removing turf, paying people to remove turf for 20 years. They've been banking water in Mexico, making investments in the LA basin to build water treatment and recycling plants in LA in return for a portion of their Colorado allocation. And then locally, in terms of in addition to the turf removal, which is primarily coming from the residential single family and multifamily, which is, those account for like 60% of the consumptive water use. The next highest one is, almost 15% now. It's commercial and industrial. So that's where the water district was really focusing on the evaporative cooling ban, because that water just goes in the air and we can never get it back. Were there any other questions, Stacy, up until this point?
Nope, no. Oh, wait, actually, yeah, there's, sure, would they go back a little bit? I'll go ahead and ask them. How do we address our region's lack of sophisticated labor for implementing green building technologies? And how can specialized training and motivation be introduced on the construction side?
That is awesome. No, that's a really great question. And, I think we've had really good results with workforce training programs, many of which came through the trade unions. So the IBW, electrical union, has been training solar installers, residential and commercial and industrial solar installers for years. Journeyman electricians, and so I think there's ability to continue to grow with that, particularly with the Inflation Reduction Act, and also just the rising cost of energy in Southern Nevada, and in Northern Nevada. That people are going to continue to use solar PV. The cost of PV has been coming down for years. It's kind of leveled out. However, it's years ago, you had to have like a 50% rebate to kind of make it pencil. And now we're seeing clients ask us about solar on almost every project. They at least want to find out, hey, how much can we do on this project? What's the price going to be? And what's the rough ROI going to be? So to me, I've just in the last, 5-6 years, I've seen an absolute sea change in the demand for renewable energy. So, and I also think just, some of these other low energy technologies, materials and so forth, and just different, the trades I think are set up in Nevada to be able to adapt to this, and we've got a long history of pivoting and sort of developing the workforce that we need. So I would kind of push back that we need like this necessarily a real a highly educated or specialized workforce to be able to do this stuff. I just think they need the training to be able to move in that direction.
Hey, Rick, let me chip in on a couple of other supporting pieces of information to answer that question also. As part of the Inflation Reduction Act, which are federal tax incentives and tax deductions for businesses and enterprises to implement energy efficiency strategies, one of the additional bonuses, depending upon the technology, it's worth another 10% incentive, is for having workforce training. It's basically apprenticeship programs. So if you can prove and show that that's part of some of the workforce on a particular project, there is an additional incentive involved in that. So the government is trying to help support that also. I would tell you also that one of the things that Train Technologies does when we work with higher education institutions and with some school districts is we implement a program called VL3, and that stands for Virtual Learning Living Lab. It is basically a mirror of the automation systems installed in these particular situations. And it is part of an NC3, which is a National Coalition of Certification Centers, to teach students about data analytics, which can be used for a variety of industries, not just for HVAC or building automation, but it is meant to encourage students to move into and to help institutions teach students more of these technologies of the future. So there's a couple other things that are being done to help support that effort.
No, thanks very much, Matt. And you also helped me remember a project that we did the Green Globe certification for the city of Henderson. It's called the Center for Excellence, and it's built right next to the new Haas Motors kind of factory out in Henderson. And that facility, one of the main purposes is to do workforce training, to train basically mechanics on how to work on electric buses and electric commercial trucks. So I think that's a perfect example of what we're talking about. Okay, was there anything else, Stacy?
Yep, I got a couple more. Okay. How do we get Southern Nevada Water Authority to stop promoting artificial turf? Seems counterintuitive to replace a water-intense material with a heat island contributing fossil fuel produced material.
No, that's a great question, and my only response to that, which is the same that you'll get from the Water Authority, is we need to plant more trees. So just like if you're replacing turf with even just with a decomposed granite, it's going to be naturally hotter. It's going to be cooler than asphalt, however, in concrete. However, it is going to be hotter than grass. Anything other than irrigated turf is hotter. So, but we have to provide shade for those areas as well, because if it's a sports field, maybe a dog park, something like that, those there's still a use for turf grass, and in some instances I think it is better, and it's safer for athletes. They don't get hurt as much, and it's better for concussions as well. So
okay, and then just one more.
Yeah.
Are you aware of the provision in the 2024 IECC requiring renewable energy production for commercial buildings larger than 500 square feet? This provision is likely to be killed statewide during the code adoption process. Do you know what other states or jurisdictions are doing?
I don't. Well, I can tell you definitively that it has been killed, because I was in the code adoption room when they voted on it. I'm part of the committee with AIA, our placemaking committee, and one of our things is attending those hearings and letting the architects' voices be heard. So what other states have done, I do know in California they have a requirement for buildings over a certain size. It's much larger than 500 square feet, if that was the number that was listed. But where you have to have a section of the roof that's called solar ready. So the only requirement is that you don't put your rooftop mechanical unit or skylights or anything in a certain area. So you're providing some amount of square footage on the roof for future installation of solar. So and I think that's just a really good best practice anyway.
Okay, that's it for
Okay.
right now.
Okay. All right. Well, I apologize if I've been talking too long. However, hopefully you can all see that I'm really passionate about this. So please forgive me. To the books, I'm going to go a little bit faster though, because I want to make sure we have plenty of time for Matt and for Q&A. So these are two of our favorite books. These are our kind of little Bibles that we keep in our office, and they're dog-eared and everything. And we actually produced a what's called a Net Zero Design Companion. It's just a little handy downloadable free book. We'll send the link, or the link will be further on here. But a lot of the information we got out of these two resources. So I'd highly recommend buying these books and keeping them handy. I mentioned this before, but if the client didn't want lead, we're off the hook, right? So I think those days are gone. We can't just say, all right. I asked the client if they care about green buildings. They said no. So I'm just going to tell the engineers to do code minimum. That doesn't cut it anymore. And going back to the AIA ethical standards and rules, we really need to educate our clients on the benefits and also the impacts of their decisions. And we need to frame it in a way that's like, this is it's not a guilt trip, but this is a smart investment. We're proposing a way that you're going to get a better building for essentially the same cost or very, very close. So you're going to have a better investment with better resale value. In Southern Nevada, I remember during the bottom of the recession, there was like about four buildings that I knew people that worked there. And those office buildings were something like over 90% occupied, where there was a total exodus from the office market in Las Vegas. So there was just huge vacancy rates everywhere. Those four buildings were all LEED certified buildings, and the reason they had a high occupancy rate is because they had a lot of state government agencies as well as federal government agencies. So those are ideal tenants because they sign long leases, and those organizations or those agencies are also required to give a priority to green buildings and certified green buildings. And then just the productivity, employee productivity, and just reducing sick time. If you can improve productivity like 1%, you're gonna more than likely double the amount of savings that you're gonna get from energy. So having employees that are a little bit happier, they have a little better control of their thermal environment, little fresher air. They're gonna be happier, and they're gonna be more productive. And I think just relating to the standard of care, right? Like, if we approached sustainability with the same vigor and importance that we place on fire and life safety design, I think it would be the sustainable aspects of buildings would be much less likely to get VE. You can always say that this is critical to the building design of the program, so we can't get rid of it. And just some of the tools and guidelines. The big message I want to get across today is we need to design above code minimum, right? Like, we just can't do that anymore. So, and all that really takes is setting some design, performance goals. So looking at the energy use per square foot, the EUI, based on your climate zone, and there's some really great easy resources tables you can go to look this information up. And also lighting power density, not overlighting spaces, making sure we have good controls there, and developing a water budget, both indoor and outdoor. Just these three things are a great, are a huge step in the right direction towards net zero buildings, and also just towards creating green buildings that maybe the owner might want to certify those as a lead existing building down the road, right? Well, you're able to tell them, they're like, yeah, this is pretty close to a lead certified building, so you have that option in the future. And really just not, I want to encourage everybody to just not cede power, to your consulting engineers, right? At your kickoff meeting with your MEP engineers, go in there with questions, and go in there with, hey, I want to, here are some goals that we want to go above code. I want to get your input and your feedback. However, we're going to get creative about this because we're not going to spend any extra money, and we want a higher performance building. So that's really, I think, the first and biggest step we can take towards moving there. And then also just using the Leader Green Globes certification system, just use their score sheet as kind of a, as kind of a guideline, like, hey, how close can we get to some of these points? And particularly the existing building score sheet is, I think, a great way to just say, hey, we're going to do what we can on this project, and if we just lower the energy and water use, there's probably a 75% chance or more that you can certify that building after it's built. And then also just referring to Living Building Challenge, their net zero information and the pedal certification is also a good guideline. And then I'll show you the desktop companion that we created. Okay, quiz. Does everybody on this call know what climate zone you work or live in? Because you should. And if you don't know it, you're going to know it now. So write these down. These are all the counties. We have, basically 4B, up in the north, and down, or 4B in the south there, and then up in the north there's a little difference between or 3B in Clark County, but up in the north there's a little difference between the Carson Valley and the Reno Tahoe Valley. These are just two really great tools, and I'm gonna go through super quickly. The AIA framework for design excellence. It's an awesome menu of just resources for designing an all-around healthy, high performance building that's also equitable. And then what I really like about it is they have these kind of three different choices you can pick, where it's just kind of general best practices or high impact. And this one is, if you can only do one or a few things, here's what you can do. Just do some preliminary energy modeling, setting some performance goals, and designing an all electric building. So no gas appliances or mechanical systems. And then this other tool is the 2030 palette, which comes from the 2030 challenge. It's really great. It's really graphical, and you can just sort of click through these different things based on different site situations and ecosystems, and then it has a menu of options that you can go through. So it's a great learning tool, I think, for young and old architects to kind of understand how these systems integrate with design, and it can also be a nice tool to kind of illustrate some of the design intent with your clients. And I'm going to go through these steps really quick. So this comes from the Oregon Zero Energy Collaborative, which is a really great resource. I already mentioned just setting energy goals. Here's the EUI target setting. Pick find your climate zone there, find your building type, and it'll tell you, what your optimal EUI is, right? And then you have that conversation with your engineer, say, how close can we get to this? And what are you going to do creatively to get above code? Optimize orientation. I mean, we learn this in architecture school, however, and we don't have a lot of control over building orientation, unfortunately. However, we do have a lot of control over the placement of windows, the number of windows, and the, the window wall ratio, as well as designing the roof for future solar using cool roof, and minimizing glare and optimizing daylight. Designing a high performance envelope. I mean, I think in my experience, architects that I've worked with, they generally just sort of go to the IECC and look at the table and like, okay, what's the minimum R value? Okay, I have to keep this project on budget. There we go. I've got a R40 roof, R19 walls done. So, but they're not thinking about thermal bridging. You're not thinking about, is it better to have the insulation on the top of the roof where it's outside of the thermal envelope, as opposed to just kind of useless bad insulation that's on top of the ceiling? Making those decisions that's cheap. Those are cheap materials that will offset the cost of higher performance mechanical systems. So the whole goal of net zero energy design is to reduce the loads, reduce the interior loads, and then proportionally reduce the size of the mechanical system. Speaking of high efficiency mechanical systems, also looking at ventilation, indoor air quality, specifying higher SEER rating units, and also looking at other technologies, such as VRF and heat pumps. If your engineers are saying, okay, we've got a budget constraint on this project, so we're going to do DX cooling rooftop package units. So when you hear DX cooling or rooftop package units, that means you can just translate that in your mind to be code minimum. Okay, so what else can we do? That's the question. What else can we do? Can we add an economizer cycle? Can we do variable speed drives and pumps? What can we do with the budget that we have? Everybody knows about Energy Star appliances, but also integrating smart controls and daylight harvesting and daylight sensors as well. Offsetting with the renewable energy. The PV watts calculator is really great. This is one of the many free tools that are featured in our resources at the end of this presentation. But you can just put in the size of your system and your area, and it'll give you some really good options for solar on your particular project on your site. This is our carport at my house. It's a 10 kW bifacial system that is offsetting 100% of our site. We have a 2,500 square foot house in a 500 square foot casita where my mother-in-law lives. And finally, measurement, right? Like one of the criticisms I hear about LEED and other certification systems is like, hey, it's all modeled energy, it's all theoretical, and then the owner moves in, and we have no control over how they manage the building or anything. And I've even heard stories of some facility managers just like kind of turning off some of the efficiency equipment or disabling it. So measure it, right? We owe it to the owner to prove that our buildings are performing the way they've been designed and engineered. And even if commissioning isn't required on a project, Green Globes certification does not require commissioning as a prerequisite. However, we push for it. We're like, this is really, it's cheap insurance, and it's really just a great way to make sure your building's working optimally. And also ongoing monitoring, being able to use some of these dashboards are a really great way for managers, facility managers, and also just building owners to be able to affect occupant behavior by showing them like, hey, the choices we make are actually affecting our energy use. So behavior is a big part of efficiency. This is just one of the pages from the design companion, and I'm going to just sort of skip through these. You can see these in the slides that'll be provided after the presentation, but they're also in the design companion. downloadable ebook. But these are just sort of like really good low cost, interventions that you can do. And then these are some mostly free tools over there on the side that you can, you don't have to do a full-blown ASHRAE energy model. You don't have to, build your entire project in Revit and run it through Safari, to make some early shoebox energy building energy model decisions. These things do that, and there's the climate consultant, the little sun there is my favorite. It was developed by UCLA. It's been free for many years, and it's super easy to use. You don't have to know anything about energy modeling, but you just input your square footage, some site information, and it spits out some really good design information. Just some more of these cheat sheet things. Getting down to low carbon steel and structural systems, like minimizing the amount of concrete that we're using on a site, on a project, including minimizing flat work out on the site. It affects the urban heat island, and it's just, if we can avoid concrete, do gravel pathways if we don't have ADA accessibility issues. Anything we can do to provide more shade and reduce the heat that's generated by our site, including cool roofs, and shaded parking. Shaded parking obviously is awesome because they can easily add solar to it in the future, and we always advocate for running some empty 1-inch conduit out to the parking lot as well, so they can retrofit easier. Just a couple of other examples, just in your specifications, right? Just having a really robust Division 1 spec that includes sustainability measures, and then relating those back to these other key divisions 3, 5, 7, and 9. So that, and then getting those in the drawings as well. So if they're in the drawings and the specs, it's much harder to have something bid incorrectly, and it's much easier to defend it later if it's going through the VE process. And also, if the sustainability goals and performance goals are listed in the project program along with the room square footage and uses and adjacencies and all that, and the owner buys into that, if it's in the program early in design, you're much more likely to have those items stay in, regardless of whether it's a LEED project or not. And then finally, I'm not going to read all these to you, but I also want to just point out that these labels, when you're looking at materials and researching what you want to use on a project, it's really a nice, a quick way to just kind of keep an eye out for these legit. These are third-party, industry labels, most of which have ANSI certification and everything. So if you're seeing something that's eco-friendly or these more generic things, just be suspicious. But these are the legit certifications that when you're reviewing submittals, these are you can look for these and say, yeah, we should be in good shape. More ideas. I think I've mentioned most of these, but also showing the air barrier layer on building sections, right? Illustrating where these sustainable systems are in the building envelope and the design, having them integrated in the drawings and obvious. It just makes them much easier to make sure that they get built properly. Real quick, couple example projects. This is one of my first projects. As a young architect in my former life, this was a bachelor's quarters in 29 Palms at the big marine base out there. This was a near net zero energy project. It had a 1.4 megawatt PV that was just all over this like 12-acre site. We had to stick it everywhere we could on top of the parking garage, and then we also managed to do a subsurface irrigation system that collected all the laundry gray water, and so we managed to have a pretty nice looking relatively lush desert landscape without using any potable water at all, and we got LEED Gold certification on that. sustainable design is not doesn't it can also be possible on lower budget projects, including affordable housing. Nevada Hand, one of the biggest affordable housing developers and managers in Nevada. They build sustainably on every project, so they integrate solar and provide a really good quality product that is healthier for their low-income families and seniors and lower cost to operate. And then right now we're working on a project for the city of Phoenix, where it's a homeless navigation center, and then it also has a transitional housing on site. So these are shipping containers, and they come with solar and their solar and battery storage as well. And this is my pride and joy. These are a couple of little houses that we did for Habitat for Humanity several years ago. We managed to get LEED Platinum, and they're extremely low cost for these families that are trying to create generational wealth. Thanks very much. And there's the link here to the Net Zero Design Companion. So this is a free download.
While we leave that screen up for a second, you want to take 2 questions?
Of course.
Matt? Okay. So the first one, in the Tahoe Basin, photovoltaic panels are not practicable because of snow accumulation and surrounding trees. What would be an alternative method for energy production?
Yeah, well, Matt's going to give you some really good options
Okay.
when he starts his presentation. However, I think geothermal heat exchange and also thermal storage, well, particularly geothermal heat exchange in that climate is so basically pre-warming the water for the and doing a radiant heating system. So basically, I would say just bringing your loads down to zero. And then also, if it's a new construction project, following the passive house design standards, and those also apply to commercial as well. But the idea is to just get your load down to next to nothing, so that you can heat and cool the space with like a very small heat pump.
Okay, and then one more. Is there a beneficial impact to EUI to wire lighting circuits for low voltage?
Oh boy, I wish I knew that. No, I really don't have an answer to that. However, it is the new energy code is starting to really pay more attention to plug load management. So as is ASHRAE. So we're moving in a direction where in the not too distant future, you're going to be able to turn off, when the office is closed, you're going to be able to turn a switch and shut off all the receptacles that are not serving, like critical equipment. So that's coming. However, it's also additional conduit and wiring and expense. So I've heard some hand wringing about that. But what we do in our office, and I read a paper about the Stanford University, and they provide they're called they're smart plugs. So they're plug strips, but they have a motion sensor. And they have some of the plugs are on all the time, and some are switched. So when the occupancy sensor senses that nobody's been in the office for 45 minutes, it shuts down the power strip. So that's I think a kind of a flexible way to deal with plug management. I hope that answers your question.
Okay, if you want to go ahead, yes, we'll have Matt go ahead, and then we can take some more questions at the end.
All right, very good. Thank you, everybody. Welcome this afternoon. Appreciate your attendance. Thanks, Rick, for turning it over. A number of the things that I will talk about today are going to dovetail very nicely into the first part of the presentation that you just saw. The learning objective for this part of the course is to give you some education in regards to the Inflation Reduction Act, which is a tax legislation package our government passed a couple of years ago now, that has a number of incentives in it to actually help afford and make more affordable much of the discussion that Rick discussed with you earlier in the presentation. I will give you a couple of ideas, a big picture of how this came about and where we're at. I will go into a little bit of the tax specifics, although by no means do I intend to make anyone a tax expert. We do have a team of subject matter experts within the company that work with our clients to develop estimates of pending tax incentives. However, when it comes to the final numbers that have to be submitted to the IRS, we do employ an outside consultant from a tax attorney to help finalize those, because you don't want to make a mistake with the IRS, that's for sure. And then last part of what I will show you is a couple of examples of projects that are in process where we've estimated tax incentives, and an example of a project where the tax incentives have been paid. In fact, that's the project on the screen that you're looking at there. Yes, there is water in the desert. Yes, that's Phoenix. And that's the ASU stadium actually right behind it, if any of you are familiar with that particular area. So let's talk about for a moment the market that we're all faced with for our owners and some of the issues that we have to deal with that affect our designs, that affect what we propose as potential solutions for them. If you think back over just the last few years, how many changes have taken place? It's nearly unprecedented. Think about what happened with COVID just 4-5 years ago now, and how that made people think about indoor air quality, especially as pertains to schools, for example. We had a rash of legislation that came out to help schools afford equipment to be able to account for equipment that help to clean the air and keep our kids safe. Obviously, it chased most of us home for a long period of time, which then precipitated kind of the second major trend, which is this whole remote work phenomenon. And as you see from the news, you can tell that companies are trying to figure it out. You know, Amazon just announced that they want everybody back in the office 5 days a week. Our company's taken a more hybrid approach of 1 or 2 days a week and the other days from home, depending upon your job situation. But how does that affect what we're trying to design for space and how that space is accounted for? And then, of course, in the last couple of years, you've seen a real focus in regards to sustainability or ESG initiatives that are becoming very prevalent for many major corporations and trying to achieve a number of those goals. So again, how do we account for all that? Well, this stimulus package, in fact, let's go to the next slide and I can discuss that because I think it will pertain nicely. And that is that the stimulus package is one that helps the affordability factor. It helps us to be able to affect better green design. It encourages sometimes somewhat more expensive technologies. But as I mentioned earlier in Rick's presentation, the life cycle cost analysis of these things, when you take into account the stimulus, makes a big difference long term for building owners. It makes them much more cost effective. So what you see in this graphic here is what traditional expenditures have been for the federal government for many, many years. You know, all through the 90s and the early 2000s, we basically just had a few basic tax incentives and a few energy efficiency rebates, things of that nature. And then in 2009, when we had a recession in this country, the government introduced the ARRA, American Recovery and Reinvestment Act. And there was some dollars there. I mean, I'm not denying that a couple billion is short change, not by any means. But when the Inflation Reduction Act, together with the CHIPS and Science Act and the Infrastructure Investment, when those were passed in 2022, the amount of spending that the government is infusing into our economy to encourage energy efficiency design has nearly tripled. The dollars involved are significant. It's almost difficult to get your head around if you think about it. For example, every one of the numbers on this screen, save for one, ends in a B. That's billions, billions of dollars. And they're in all parts of our market and pertain to all parts of the different technologies that are available and the different styles of buildings that we have in this country. Again, it's an unprecedented amount. Now, some of it, like, for example, the IIJA, the Infrastructure Investment Act, that's primarily for transportation, for example. But the Inflation Reduction Act certainly applies to energy efficiency. The CHIPS Act has been a huge boom for obviously semiconductor production, things of that nature. Keep in mind, too, that stimulus money from the government is not the only dollars we have available to help fund these projects and make energy efficiency more affordable. There's a number of other dollars that can be incorporated into projects, and I have an example of that as we move further through the presentation. But things like local utility rebates is another valuable source to help fund these projects. Rick referred to the water moratorium in Southern Nevada, and the water authority there is offering dollars that are significantly changing the economics of projects. I have an example of that also that I'll show to highlight that. The other savings that are available when you look at operational cost savings, energy savings, and even avoided future capital cost savings if you're working with an existing building that maybe is doing a renovation. So those are all real dollars that can be calculated into a payback for a potential building owner. Again, I don't intend to make everybody a tax expert. What I'm trying to show you here is the breadth of the dollars that are available from different agencies. It's not just the IRS with those first two pieces of the tax code, the 179D and the 48 ITC, which I have some further detail that I'll share with you so you have a better idea of what some of those can impact. But more so that there's a number of other dollars available. For example, under the Greenhouse Gas Reduction Fund, that's actually a lending fund for national clean energy that pertains to things like solar, that pertains to wind, technologies such as that, where there's 7 billion for solar, there's 6 billion for wind, and those also have some targeted markets that the government hopes to incentivize that have to do with, for example, low income, disadvantaged markets. They also have qualifications called energy communities. There's a number of factors that go into determining what an energy community is. But believe it or not, even Las Vegas and parts thereof are considered an energy community, which enhances the incentive that is available. Traditional funding, for example, the EECBG funds, those again are competitive grants for energy efficiency, weatherization. I'm working with a municipality currently in Arizona that just applied for those as part of the project that had to do with weatherization. It had to do with some lighting. On a $5 million project, they expect to get about 200 and some odd $1,000. It's obviously not enough to pay for the project, but when you add that to all the other incentives that are available, it makes a difference. It starts to have an impact. Stacy, let me know if any questions pop up as I start to walk through this.
Sure, I will.
All right, very good. Thank you. So this tax credit under Section 48 is something that's been around for many years, actually. However, through the Inflation Reduction Act, the federal government, I guess you could say, turbocharged this incentive because the base rate for years was always just 6%. There was the opportunity on some solar for a while that you could get up to 30%, and sometimes it would knock back down to 25%, what have you. But in this case now, not only solar, but we mentioned earlier in the presentation about thermal energy storage and also geothermal now qualify for a 5 times multiplier. So that's a 30% incentive as a tax credit to the building owner to implement these energy efficient technologies. Again, there are kickers, if you will, or additional incentives. For example, depending upon the technologies or the product that's used, there's an additional up to 10% if it meets domestic content requirements. I mentioned the energy communities requirement. That map actually changes every year. And if there's questions regarding an area that you're working, that's something Rick or myself can help you to determine if in fact your community might qualify, or your property within that community may qualify for those additional incentives. The fact of the matter is, there's potentially, depending upon the property, depending upon the technologies, there may be as much as up to 50% of the cost of these systems that would qualify for a tax credit. There's some technical details that the IRS requires, but just keep this one piece of information in mind. This will help to understand better what some of the requirements are. And that is the IRS has a term that they call functionally interdependent. And what that means basically is anything that is connected with these systems that is integral to the operation thereof. So if you think about a geothermal system, for example, not only would the piping in the ground qualify, but any of the pumps, any of the equipment, i.e. heat pumps, the air handlers, and any of the ductwork that is associated with those systems, those are all considered functionally interdependent. So it's not a tax credit based upon just the cost of the equipment itself, but all the other operational pieces that help to make that a functioning system. So therefore, that tax credit grows pretty quick and in a fairly large way. There'll be a tax quiz on this afterwards. No, I'm kidding. Trust me. I have a hard enough time answering these questions myself. I'm trying to build awareness so you understand that, in fact, there are lots of opportunities for this. So the 179D is one more section of the IRS tax code that's important for everyone to understand and know, because again, this has the potential to supercharge some of the additional monies that are available for projects. Keep in mind that this also has been a long-standing tax deduction, and it always had some fairly low amounts. You can see the base deduction rate is 50 cents. I think the original rate was like 37 cents a square foot. So not a big incentive. But what's really changed is that with efficiency gains beginning at 25% efficiency gain, and I'm talking about like in a retrofit situation here, although it does also qualify for new construction if you can show an efficiency gain over the ASHRAE 90.1 standard, which goes back to 2017. So it's a fairly low bar to get over, frankly. To get up to potentially $2.50 a square foot, up to as much as $5 a square foot. Now you're talking about real dollars that make a real difference. The other thing the IRS did when they updated this part of the code is they made this deduction applicable to not just private entities, but also tax exempt entities. So think schools, think municipalities, places like that. There was some confusion initially as to how that applied. There was a calculation where it was paid directly back to the tax exempt entities. However, it's since been revised that now that deduction comes back in the form of a deduction to the designer of those facilities. So that would be yourself, your MEP team, people like that. So there was too much confusion, and there was really no way for the government to have those tax exempt entities receive those dollars. So now they're allowing the designer of these systems to take advantage of that as part of these deductions. Little confusing, but again, just know that there's lots of dollars out there. You have projects to do. Again, Rick and myself be a good resource. We can help guide you through it, give you some preliminary estimates of what potentially could be available.
Okay, I do have a question.
Okay.
Hey, do you know of any design consultants or manufacturers that are doing 179D deductions for tax exempt entities?
Yes, as a matter of fact, I do. And the person that's speaking right now is one of them. So I have an example of a school district that we're in the process of doing that for right now. I have one example of that. We have several across the country where we're doing that. So yes, if you have some specific questions that you want to work through on a project that you might have, I'm happy to address that with you offline.
Okay, and I do have one more.
Sure.
Do any of these possible incentives apply to organizations that are not taxed, such as private religious education facilities or religious facilities? Or are they all provided by tying incentives just to tax forgiveness?
No, so that would fall under nonprofits, and there are special provisions for nonprofits. I believe the calculations are the same, and those deductions would go back through the designer. I need to confirm that detail, but that's my understanding of it. We just haven't worked with that a lot.
Those are the only questions right now.
Okay, very good. Thanks, Stacy. All right, quick engineering lesson here, since this pertains to some of the technologies that are incentivized under the Inflation Reduction Act. I'm certain you're all familiar with electric batteries. That technology is evolving quickly. It's becoming much more cost effective. It is being able to be deployed on much larger scale for backup storage for solar systems. But the government also realizes that there's a technology called thermal batteries, which is the thermal energy storage that qualifies for the Section 48 investment tax credit. And a thermal battery is a big tank with water in it. That's all it is. And the way that works, I'll show you on the next slide. The way that works is a building has a chiller. It would be typically an air-cooled chiller, although you can use water-cooled also, with a series of pipes and pumping and what have you. And the basic philosophy behind it is this, that at night, when the rates are lower and there are not demand charges, is when your chiller runs and produces cold water that becomes ice in these tanks. And we store ice, we make ice and store it overnight. And then during the day, when electric rates are higher, our chillers don't run. All that runs are our pumps where we're melting the ice and we're using that cold water to pump through buildings to cool the buildings. So you're still consuming energy. However, you're consuming a lot less energy because you're not running a big machine all day long and having to worry about higher utility rates and demand charges. I mean, there's a few more engineering requirements than that, but that's the basics of what this does. And again, it is a system that is being incentivized by the government because of the efficiency involved and because of the life cycle cost analysis, life cycle cost advantages, I should say, over time. An example of how that technology can make a difference, especially as related to Las Vegas, it is amazing. We are in the process. I'm not at liberty right now to reveal the name of the client, but it is a large facility that is involving a central plant upgrade, and initial budgets are about an $8 million project. So when you factor in just at 40% for the Section 48 investment tax credit, that's about a $3 million federal incentive that this institution will be able to use against the first cost of this installation. And in Las Vegas, since we have the added incentive from Southern Nevada Water Authority, that equates to $1,500 per ton, a ton of air conditioning. So it's $1,500 per ton, and based upon the size of that system, that breaks down to approximately another $3 million. I've worked in this industry my entire career, and I have never seen incentives to this extent that have impacted projects this significantly. It's pretty remarkable, actually.
If I could add to that also, Matt, real quick.
Thanks, Rick.
I completely agree. And since I first learned about the IRA and how it applies to to these two particular technologies, I was just completely flabbergasted at how at the whole concept that buildings with large internal loads in a very harsh arid climate like Southern Nevada could actually have a pathway to net zero energy without without installing like 40 acres of solar to offset, or buying renewable energy credits offsite. So and that those technologies would be with the can be on par with regular code minimum mechanical systems. So to me, like I completely, we've talked about it, but it's a complete game changer, and it's the first time in my whole career that I've seen an avenue to get to net zero, but on a large scale.
Yeah. Thanks, Rick. I'm finding the exact same thing. It's pretty remarkable right now. All right, well, let me give you a high-level example of the impact that I keep getting excited about as I talk to everybody here. So this is this is an example based upon a real project that is in the estimating phases right now. So we're estimating a project size of about $5 million. It's an upgrade replacement type project. There is some new construction that is part of this particular project, but through a number of what we call energy conservation measures, that's the energy savings box, we're calculating approximately $800,000 in reduction in utility bill costs. So that's real savings. That comes right out of their operational budget. That's $800,000 annually less that they're going to pay for their utilities. So that's one bucket of savings. Federal tax incentives based upon the technologies that we intend to deploy is approximately another $900,000. There's a small grant, and I don't mean to minimize $400,000 as being small because it's real dollars, but there's a grant that they've applied for. We're awaiting approval. We anticipate it'll be about $400,000. And then just from the power company themselves for just rebates for the electric consuming equipment. This is nothing to do with water. This is actually an Arizona project. The rebates from the local utility we anticipate will be about $300,000. So the point is that on a $5 million investment, the customer is really looking at about 2.6 million, or about half of the original investment that they need to come up with to be able to fund this particular project. Discussion's a whole nother discussion how we get there, and that's certainly something that can be done. But the point is, when you leverage these incentives, not just the federal tax incentives, but everything else, it really begins to make a difference on the economics of a project. So let me show you a couple of examples. These first couple examples are ones that are near finalization. So we don't have customer names and we don't have final numbers, but these are ones that are in process. The last project that I will show you is one that's a done deal. It's been cemented and finalized and what have you. So this is a couple 100,000 square foot building. The example here shows you that there are two parts of the project that qualify for federal tax incentives. So you've got a solar system and you've got thermal energy storage that we discussed a moment ago. There's a number of other parts of the project that go into this regarding air handlers and energy conservation measures. We've even included in this example a maintenance agreement, because obviously equipment tends to do what we call drift over time. In other words, it's like you need to change the oil in your car every 10,000 miles to maintain peak efficiency. It's the same thing. So why let your energy savings go away? So on almost a $7.5 million project, after all is said and done, again, initial out-of-pocket cost or first cost to the client is just over $6 million. So it's about $1 million savings with the different incentives. And again, keep in mind, this is not including, I'm not showing in this example, energy savings, and I'm not showing utility rebates. I'm just using this as an example of just federal tax incentives. You'll notice too, or one other thing I guess I should point out is, in terms of these additional benefits or additional kickers that are available on this particular project, it does meet prevailing wage and we talked about apprenticeship requirements. So that will be a part of this project, is the apprenticeship, so that students and trade workers begin to learn advanced skills for energy efficiency technology. So there's an extra 10% that is due to the owner because of that being included. However, this project does not meet domestic content requirements. And again, that's a complicated calculation. I can show you if you ever want to take a short nap. I'm happy to walk you through that. But that does not apply here. The other thing that I'll highlight, again, going back to the tax codes, we looked at the 179D before, and it starts at a 25% efficiency drop. This project only got to 17%, so they wouldn't be entitled to the additional kickers on this. But even without those couple of additions, you're still at almost $1 million in additional incentives. So that's one example. Here's another example of a hospital down in the southeast that we're in the process of putting together. And here's one that actually has 4 different categories that qualify for tax incentives. in addition to some other energy efficiency measures that are being implemented. You can see those on the screen. It's about $12 million investment on the part of the hospital. And in this case, they did achieve a 28% energy efficiency improvement. So that will help with that 179D deduction. They are getting the Section 48 deduction for the solar and for the thermal energy storage. So that's nearly a $2.5 million incentive in year one. That's a huge first cost reduction for this particular client. And in this case too, to answer the further answer the question that came up earlier on that 179D, since the hospital is a not-for-profit, that 179D goes back through the designer of this system, but obviously is then reflected still off the first cost of the project. All right, last example, and then I'll show you another project that is closed out to answer the question that came up earlier regarding school districts, non-taxable entities. So here's a school district in, this is upstate New York, actually, is where this one is. Two different technologies that qualify, again, solar and ground source heat pumps. So that would be thermal energy, or not thermal energy storage, sorry. Help me out, Rick. All of a sudden I drew a blank. Ground source heat pumps.
Geothermal heat exchange.
Geothermal, thank you. Oh my
Yeah.
goodness. Jeez. So that qualifies. It's about $17.5 million in total. We are just about to start within the next month or so, just finalizing final details and contracts and what have you. This one didn't quite make the 25% energy efficiency improvement, but it did, again, meet prevailing wage and the apprenticeship requirements. This will be a project where we'll BL3 lab that I mentioned earlier, so we can teach students about those advanced technologies. And again, it's about $1 million in potential tax incentives. So there's 3 projects in 3 different markets of the country, in 3 different vertical markets. And projects of different size. So you get an idea of the impact that these incentives and energy efficiency really starts to make.
And Matt, if I could jump in real quick, there are not a gigantic number of certified or non-certified truly net zero energy, schools around the country. However, the ones that I'm aware of, I would say probably 3 out of 4 have a geothermal system. So that's how they're getting to, they're reducing their load by such a huge amount that they're able to afford, a modestly sized solar system to offset that load.
Yeah, most definitely. It's a good point, Rick. Thanks for highlighting that. All right, so last couple slides that I want to show you. I know it's music to everybody's ears on a Friday, right? Last couple slides. I can see everybody smiling right now. So this is a project that we started, I don't know, almost 2 years ago, I think is when this began. This is commercial office space in Phoenix, Arizona. The facility itself is only 9 years old. And wait till you see the numbers that we achieved on it, even on a fairly new project here. We just completed it in May of this year, May of 2024. What we did here, and this goes to a couple of the points that Rick brought up in his presentation about good design and doing better energy efficiency. A couple of his bullet points related to not just LED lighting, but it also related to integrated controls. And you can see the title of our project is Energy Controls Integration. Okay, so what does that mean? Let me give you a quick highlight, because this pertains to new construction. This is good design for new construction also. And that is this, that when you integrate, in other words, you have both your lighting controls and your heating and air conditioning controls on the same platform, on the same software, so that they are talking to each other at the same time, you are able to achieve even greater energy efficiency. So think occupancy controls, whereby for conference rooms, for common areas, that you have occupancy controls that bring lights on and off with the heating and air conditioning based upon occupancy. The other thing that is important when you think about energy controls is this. LED, no matter how you design it, for whatever kelvins and color rendition and all of that, is typically much brighter than what's required in a given space. And the proof of that is this project, where we've also integrated dimming controls. So this is a very interesting case study in how this project came together, such that when we first did a floor, we went floor by floor each night to retrofit this project. And each morning, when like floor number 10 came in and turned the lights on, the lights came on at only 80% of capacity. And now that the project has run all summer, almost every floor is running at about 60% of capacity. And the occupants are very happy. People don't get headaches any longer like they did from the halogen bulb, or rather the incandescents that were in there. And that light level is very sufficient for accomplishing work for people. So the client has picked up two main benefits out of this. Number one, occupant comfort, which in an office setting can be difficult at best, since everybody has a different temperature gauge and a different light meter in their own head, right? That's number one. And number two, when you start dimming lights and you're not running a light at 100% capacity and you're only running it at 60% or say 70%, what you're doing is you're extending the life cycle of that particular piece of equipment. Most LEDs now come through with a 10-year warranty. An expected lifespan is about 13 years. We are calculating on this particular project, since we have dimmed the lights, that we're probably going to achieve somewhere plus minus 15 years on the life cycle of those lamps. So a couple of really important things to understand about benefits beyond just the initial cost of energy efficiency. So I tried to design a slide where I put just as many numbers as I could jam onto one slide, and I think I accomplished it, because I even confused myself. But let me walk you through a couple, because these are significant and they're important. Down the left side, you can see the project financials of what the investment was by the client and what all the savings were in regards to this particular project. This is one where the tax incentives are being paid as we speak, and it's about 600 and some odd $1,000. So their tax attorneys actually recommended yet another section of the tax code for a qualified improvement project. Anything that's energy efficiency really qualifies for that. The benefit with the 80% acceleration in the depreciation, which is what that qualifies for, was actually a greater benefit to them than taking full advantage of the 179D deduction. So it was a combination of both of them. I know that sounds really complicated, and it is, but that's why we work with tax attorneys to figure this stuff out. So you can see also down at the bottom of that column what we estimate the lamp life cycles to be. And when we say trim, we mean capacity, basically. It's a technical term in our industry. So 100% is about 15 years. If we were to trim it all the way to 40%, we'd be at 25. Like I mentioned, we're running at 60%, so we're somewhere in between there at this time. So if you look at the right side of the screen, what you see is a couple of things. You see before and after, with and without tax incentives. So the top 4 numbers are things we calculated initially as we designed the project. The actuals are the as-built down at the bottom. So annual energy savings over 300,000. And what's really significant, though, is the with and without tax incentives, what it did to a simple return on investment. We didn't do anything with life cycle cost analysis or anything. We just did the basic, what's your return on investment based on your energy savings divided into the project itself, taking into account some rebates and a couple other things. But so with the tax incentives, we dropped it by 2 years, and that's with what we call a high-end control system that has dimming capability, that has the integration into the lighting control system. Casey, any questions?
Nope, no questions.
Okay. Look at that, Rick. We are 1 minute till our time limit. How do you like that? And I have one last thing to show. This is the kind of information that can be produced to also help you show the benefits of doing good green design. And out of this project that we just did here, out of all the tonnage of all the things we recycled, we had 90 pounds. That's it, 90 pounds out of over 25, 26 tons of material we recycled. Only 90 pounds we had to throw in a landfill. So it does